So let's walk to this other table over there.
Okay, what can I see here?
On the left-hand side, you see again a code city for a program. The program implements a compiler written in C. The blocks represent source code files. On the right-hand side, you can see another code city. But this time, it does not represent the result of a static program analysis. It is in fact an architecture model crafted manually by a software architect. It is very much like a package diagram in the unified modeling language. The edges between the green area represent the dependencies among the architecture component as expected by the architect. A compiler has a main component controlling all other components. It is implemented by these source files. A core of a compiler is typically separated into a front end, middle end, and a back end.
I see.
The front end analyzes the input program. This part is implemented by this bunch of files. Now you may have noticed that this yellow edge turned into a green one. Yellow means expected but not yet confirmed. Green means there are indeed expected dependencies in the code. The middle end runs the semantic analysis, that is, checks whether all entities are declared and all type rules in C hold. This large part of the implementation forms the middle end. Then there is a back end that generates the code which is implemented by these files here. Watch how the yellow edges turned into green ones again.
Oh, this looks good. Why are they so shiny?
Whenever I move implementation blocks onto architecture components, an automated incremental analysis computes edges that need to be updated. The most recently updated edges are drawn with this highlighting effect. The last set of files implement generic, reusable functions. The architecture component common is intended for that. So let's move them there.
Oops, now we have red edges.
Red edges mean that there are dependencies in the implementation that were not expected in the architecture. That is, these dependencies violate the architectural design.
That shouldn't be the case, I guess.
Indeed. We may need to refactor the code or maybe should update our architecture model.
This looks like a very nice use case for code cities. It's so intuitive.
I don't think anyone would have spotted these problems if developers are looking only at the source code.